Welcome to the second class of Computing Fundamentals 1, and today we are going to review propositional logic, and we will start talking about the equivalence. How we can decide that two propositional statements are equal. So in session 1, this is what we did. We speak about negation, where we have P, a proposition, and not P, which is not the case that P is happening. Then we discuss conjunction, and conjunction are basically the AND operator, where we have two statements P and Q, and the truth table of conjunction is the same truth table you did when you have AND gate, where 1 and 1 is 1, where 1 and 0 is 0. True and true is true, true and false is false. Then we discussed this junction, and this junction is basically OR, where we have two statements P and Q, and we say the truth table of this junction is the same one as OR. So this slide is giving you a summary of all of them. So we have the truth table for conjunction, which is the AND operator. We have the truth table of disjunction, which is the OR, and we have the truth table of exclusive OR, and we call it, for simplicity, the XOR gate. In logical design in the computer, XOR, it's always true when there is at least exactly one true in P and Q. So you see that the XOR true is false, because I need at least one value to be true, not both of them. Then we have discussed conditional statement, and we say if we have P and Q, the conditional statement P implies Q is the proposition if P then Q. And this is basically, we have to refer to the truth table of P then Q, as we see here. True, if true, then true is true. If false, then true is true. If false, then false is true. And if true, then false is false. So it is okay, as I said before, it is okay to have a theory, but the outcome or the conclusion of this theory is a true fact. But the theory itself, it was a false theory. So you can disapprove it. And we will see this in a practice when we do contradiction. When we study contradiction, we will understand what we mean or why we have if false, then true. How we can put this in action? It is basically when we want to translate English sentences into a logical proposition. So study this. How can this English sentence be translated into a logical expression? Now we want to make this sentence look like a logical expression. So you cannot ride the roller coaster if you are under 4 feet tall unless you are older than 16 years old. Now, once I see if, this means I have to use the proposition if then. Okay? So I could simply now assign each portion of the statement into a propositional variable. So Q could refer to you can ride the roller coaster. R, you can ride the roller coaster. And then S, you are under 4 feet tall. Okay? So the sentence could be translated into the following. You cannot ride the roller coaster is not a Q. If you are 4 feet tall and you are not older than 16 years old. All of these, as an if statement, could lead us to the conclusion or to the premises that we have not a Q, which is you cannot ride the roller coaster. So you cannot ride the roller coaster is basically the conclusion of the if condition. It's what happened after the then statement. Another example. You can access the internet from campus only if you are a computer science major or you are not a freshman. So now let me chop this statement into small propositional statement, and I will give each statement a propositional variable. Now A, C, and F, they will be used as variable. So let's A now refer to the statement you can access the internet from campus. C is you are a computer science major. And C, you are a freshman. Now the original statement asking me, you can access the internet from campus only if you are computer science major or you are not a freshman. So I need to have F first. So I will have, for example, A, which is refer you can access the internet from a campus if you are a computer science major or you are not a freshman. Because the original statement was saying you are not a freshman. But my statement that I put when I chopped that long statement into small portion of that, I say you are a freshman. So I have to use negation at there. You can also write this statement in a different way. I could simply write it as if you are a computer science major or you are not a freshman, and in this case I will say C or F implies A. If C or F leads to A, that you have or you can access the internet from the campus. At any stage you feel you are confused about those operators, they are the same one you use in logical and digital circuits. So you can basically put the truth table with zeros and one instead of true and false, especially in the exam. So this basically represents the information using bits, and a bit is a symbol with two possible values, 0 and 1. And we said before, once we have an electric signal in the digital circuit, we say this is a true value, which is 1. And this is how binary system works. So there is a signal, this is 1. There is no signal, this is off, which means 0. Now, 1 always represents true and 0 always represents false, and the value could be used as a Boolean variable if the value either true or false. So the bit operation, they are the same. So you just convert X to P, Y to Q, and put the truth table 0, 0, 0, 1, 1, 0, 1, 1, and then X or Y, you fill the truth table based on the OR gate, and the AND gate, and the XOR gate. So it is the same what we have studied before. So all we just change, instead of true or false, we just put 1 and 0. Instead of OR, we say this is, instead of AND, we say this is conjunction and injunction for OR, and so on. Now, to make sure you understand what we are talking about, okay? Let us do a simple activity together. You're supposed to see now in the classroom page a new question to answer this activity. As I said before, you can access the course from your mobile application once you install Google Classroom as an app. It's available for Android and iPhone. Download it now, access the course using your DIT account, and you will be able to submit your answer for this activity. We have 10 minutes to do so. So the answer for this activity, as you can see here for B, you do not miss the final exam if and only if you pass the course. So it's very important to clearly state the condition, the propositional logic connector that you use, whether you are using if statement, if you are using if and only if, or and, XOR, or not. Now let us move to another interesting topic in propositional equivalence.